Good morning, this is Dr. Turner for Integrated Math 3. Today we're going to be talking about 5.5, which is the last unit for our semester. We're going to be looking at solving radical equations. So this is going to combine some of our rules of exponents in addition to what we just learned in 5.3 and 5.4. The process is going to be the same. We are trying to isolate our variable term and then isolate the variable, just like any other one or two step equation. But again, we'll throw some radicals and fractional exponents in here. So to start out, let's say we have something like square root of x minus 5 equals 6, for instance. I want to get x by itself, and right now it's inside that radical sign. So what I need to do is do the opposite operation, just like we always will. Opposite of square root is square. So we're going to square it, but if I square this side of the equation, then I have to square the other side to keep it balanced. So I take square on both sides. That's going to give me x minus 5, because those two will cancel out, and then equals 6 squared, which is 36. Then get the variable by itself by adding 5. Get x equals 41. And that's essentially what you're doing in this process. So you're sort of treating the radical as though it were a parenthetical or another type of grouping. So you want to get that isolated first, then undo the radical, and then solve like any other one or two step equation. So let's do square root of x plus 4 plus 1 equals 7. Equals 5. Okay. So first thing I need to do, I need to get that radical by itself. So I would start by subtracting 1 on both sides. Now I have radical of x plus 4 is equal to 4. Now that the radical is by itself, I can get rid of it by, again, squaring both sides. And you don't have to write that, but you can, like so. Those cancel out to give me x plus 4 equal to 4 squared, which is 16. Subtract 4 on both sides, you get x equals 12. Process is the same for any type of radical, including fractional exponents, but let's say I had a cube root of 2x plus 4 equals 5. Okay. So this is a cube root, so to undo the cube root, I would need to cube both sides of the equation. So I'm going to raise both sides to the third power, so that the radical goes away. Now I'm left with 2x plus 4. That's equal to 5 cubed, which gives me 125. Subtract 4 on both sides, and divide by 2. And if you end up with a non-integer, you can leave it as a fraction, or if you want, you can write it as a decimal. Either way, I'm okay with. Some of these questions will also just throw in like a fraction. So let's say I have x minus 6 to the 1/2 equals 7. Okay. Remember that how to convert between the fractional and rational or radical expressions. So 1/2 is just another way of doing square root. But if I was leaving it as a fraction to get this to 1 so that it goes away, I would multiply by the reciprocal. Reciprocal of 1/2 is 2. So I'm squaring both sides. Okay. Again, alternatively, if I wanted to, I could rewrite this as a square root, but the process is the same. So I'm squaring both sides so that I'm left with x minus 6. On the right, 7 squared is 49. And then if I add 6 on both sides, I end up with x equals 55. In all of these examples, we had just a single expression that involved an exponent, but I could have something out like a rational function on both sides. So 4 times x minus 3 to the 1/2 equals 2x to the 1/2. So here I do have a rational expression on both sides. As long as I have those rational expressions by themselves, then I can do to both sides like we've been doing. So I'm going to square both sides to get rid of the 1/2. But be careful, when you're squaring, you have to square everything. So 4 squared would give me 16. X minus 3 to the 1/2 squared, that would go away. And then 2x squared 1/2. That would go away. So that leaves me with this. Now I can treat it like any other equation. I'm going to distribute the 16. From here, I'm going to get all my variables on one side, so I would subtract 2x. I would add 48, and then divide by 14. Again, you can leave it as a fraction or decimal, but if you can simplify the fraction, you always need to, so this would be 24/7 if I'm leaving it as a fraction. And that's pretty much it. If you guys have questions, as always, please reach out to me or come to office hours. Otherwise, have a good day, and I will talk to you soon. Bye.